Hi, welcome to my channel and welcome to my first video ever on YouTube and also my first video on integral calculus. The reason why I'm doing this video is to help anyone who is basically doing a self-learning and also who want to understand more on integral calculus. So I will try to bring out a lot of proofs, yeah, along with the subjects I'm doing. Um, so yeah, so about myself, I'm not an expert, I'm not a mathematician, but I'm just a student. I'm just doing this to help anyone who want to do self-learning so that I learn from you and you learn from me, and I hope I create in mutual environment. So if there's anything I did wrong, I hope you will leave it in the comments and tell me and tell and suggest a better way for me. Yeah, without further ado, so welcome to my to the integration calculus. So before we start, I would like to set a warning saying that uh, for taking this journey of integral calculus, you need the knowledge of differential equations of differential calculus. If you haven't done so, please do find find a way for you to look through differential calculus, everything there. Um, because we need those differential equation or calculus to verify it and help us to understand in some of the topics here in integral calculus. All right, so without further ado, let's jump in. Okay, so first let us just review differential equation first. All right, so just really a basic one, not really like you know uh, crazy one in the differential equation, like a Taylor polynomial thing. So just basically as a basic thing. So let's just review thing first. So if I, in general, if I ask you to differentiate and any x to the power of n, so saying n is like around a some number, so what basically we do in generally is that we bring the n down here and we times x to the power of n minus 1, right? And this is a general formula for differential equations. All right, so when we study in kindergarten, high school, elementary school, whatever it is, right, we always learn something, the opposites, the technique, the mathematic technique. We learn one thing and when we learn the opposite of that thing. For example, we learn plus, then we have subtraction, right? We learn multiplication, then we have division. We learn exponential, then a to the power of n, let's say is equal to b. Then we also learn logarithm of a and b is equal to n, right? And we learn differential equation, then for sure we have integral. So basically, in general, what integral is basically in the idea is if I ask you to integrate this one, what I hope getting is this one. Okay, now I know there's a lot of, you know, there's one mistake around here, but I just leave it there. So, you know, it's just an idea. Okay, so now I'm going to introduce you a indefinite integral. Now there's a lots of things we have to cover in here, but I try my best to minimize as much as I can and make a topic mm, simplest, easiest to understand as much as I can. Okay, so let's bring that one again. Okay, so let's bring this one again, shall we? So basically, oh, just now I forgot the dx. Okay, so basically, if I want to integrate something, so first we write a notation like an S around here, and then we write the term that I want, the integrand. That's what people are saying, but I would like to call the term that we want to integrate it. And then we write dx or d something, but dy, du. That means that we want to integrate it in respect of whatever the variable we are talking right now. So for example, here we're talking about x, so it's dx. Okay, So now what I want to do first is how trying to find a way to get to x to the power of n. If you don't like proof, by the way, you can skip this part and go to the other part to see the general formula for the indefinite integral. But now if you want to see the proof, you can do it. It's just like a random solving puzzle thing. So first we want to cancel n out, okay? So how can we cancel n out? So the only way I can cancel n out is, times 1 over n, right? But again, where do I bring the n from? The only place I can bring the n from is from x to the power of n, right? It's from here. That's the only place I can bring the n out. So that means x to the power of n. Okay, so how can I eliminate the plus one? Sorry, the negative one by plussing it one. Okay, so now I also have like x to the power of n minus 1 plus 1. Okay, so in the end, what I got is, well, again, let's write everything so that we can see it clearly. Let's write everything again, we can see clearly. So now we see that this one can cancel out, so x to the power of n. And of course, from now on, from here, I have to add c. So in a general formula for integration is, so if I ask you to integrate any x to the power of any n, the general formula is 1 over x plus 1 over n plus 1. Sorry, I forgot the dx. I always do that. If you've spot my mistake, please put on my comment and let me know, because I always do this kind of mistake. So again, x to the power of n dx. So 1 over n plus 1 times n to the n plus 1 plus c. Okay, I know there's a lot of things in your mind right now. For example, first, why is it called indefinite? Second one, why are we passing c in here? So before we start, I start to attempt to explain everything. I would love us to get familiar ourselves with the indefinite integral first. So if I ask you to integrate x to the power, let's say 2, well, you are using this formula, then I get, 1 over 2 plus 1 times x to the power 2 plus 1 plus c, that'll be 1 over 3 times x to the power 3 plus c. Okay, so same thing if I ask you x will integrate all again dx. My mistake, Jesus. But again, so 1 over 7 plus 1, x to the power 7 plus 1 plus c is equal to 1 over 8 x times a x to the power a plus c. All right, great. Now I hope we got the sense of how is it going. Now they're like, so now why indefinite? Okay, so before attempting to explain indefinite, first we attempt explaining y plus c. So imagine if I asked you to differentiate x squared plus 1, and also the other one to differentiate x squared plus 100. What we would get? So the first one, for sure, I get 2x. So the second one also get 2x. But if I want to integrating 2x dx, okay, what will I get? So this is one of the properties I haven't introduced yet, but you can do it in integration, okay? So you have a 2, like a constant number inside your integrand, you can bring it out. So 2 times integrating of x dx again. So we use the formula that I introduced earlier. So we got like 1 plus 1 times x to the power 1 plus 1. And I'll just leave everything here. So this one is 2 times 1 over 2. Okay, so these two again cancel out. So I got x to the power 2. Now here's the question. Here's the question is, so I noticed two different shade have the same, product, let's say a result. But if I integrate the result, which one do I get? Like, do I for after this, do I get the x? So after this, do I mean this one? Or do I mean this one? So at the end, should I write plus one? Or should I write plus 100? Or can I write plus two? Can I write plus 400? Can I write plus pi? Can I write, c squared, speed of light square? Well, I can write, eventually I can write the whole list out, right? I write any number out. So eventually, that is the reason why we want a plus c representing, representing a certain number, a certain constant number, but we don't know what that is, okay? So that is the reason why we're adding c. And this is the reason why it's called indefinite. Because again, indefinite, we cannot define which one this belong to. So is it plus one? Is it plus 100? Or is it plus two? Or is it plus anything? We cannot define it. So that's why it's called indefinite. And again, this function is called the family of the function. Okay, so what I mean is, if you go on to Desmos and you draw this graph out, okay, you can see, for example, I'm not kind of good drawers, but we can see that it's, so for example, if it can shift one up, it can shift this one, it can shift like this, it can shift like this, and it can shift like this, right? So it can shift anywhere. So it be the least would be going infinitely, so it can shift anywhere. So this is a family of function, and that's why it's the reason why it's called indefinite. Okay, so now using this idea, okay, let's talk about some properties of integral. Okay, so now we get an idea of what indefinite integral is. So we're gonna jump into something called the properties of integral. Integral. All right. So what are the properties of it? So first, if I ask you to add, for example, let's just put a and b be a function of f. Sorry, so be a function of f. Okay, so a and b can be any function of x. Okay, so it has x variable inside. If I ask you integral two function of x adding together, did I mix any mistake over here? Oh, I did add a BS. Great, great, great. I just want to make sure. So if I ask you to integral two function add them together, what I get is the integrating of a plus integrating b, add them, integrating individually, and then add them. Okay, this is equal. And the second one is that if I have a constant number, okay, so k is a constant number, so k is a constant. So meaning it can be any number. So I can just the number two. Now I can bring the k out and I can integrate the function of a, later on. Okay. Yeah, so these are the two properties. So we can rewrite it again. So let's bring some problems so that we can apply this kind of properties in this. So if I ask you to integrate x to the power of, let's just say 3 plus x to the power of 2 dx, let's say, and of course we cannot integrate them like together, and so we have to separate them using the first properties over here introduced. So the first property over here, and so I have to separate them. So x to the power of 3 dx plus integrating x squared dx. Okay, so again, by using the formula I gave it to you just now, so I'm going to rewrite this one slowly. Hopefully, some people can, everyone can get what I mean. So plus c. Okay, now I got like 1 over 4 x to the power 4 plus 1 over 3 x to the power 3 plus c. Okay, simple. So the same thing if I have a constant, let's just say like that example. Well, let's change the number 2 to number 3, sorry, and try c. Dx. Now I got like, I bring 3 out and integrate of x squared dx. What I have is 3 times 1 over 2 plus 1, x about 3 plus 1, plus c. Will that be 3 times 1 over 3 plus c? That'd be x over 3 plus c. Cool. Cool. Now, here is a problem. If anyone noticed this, congratulations, like you are like A plus student. If you are like you're doing self-learning, you don't know what grade you're in. I'm sorry, what grade you will get in this course. So now if I ask you to integrate again x of half n, okay, and I just rewriting the formula again, okay. There is one value of n that make this whole equation gone wrong. There's only one value of n, okay, and I can give you like 5 seconds to think. But again, this thing of one value of n that make the whole thing go wrong. Okay, so 5 seconds begins. So those who spotted this, congratulations. Again, if you need more time to think, feel free to pause the video because this one is kind of a little bit tricky. So the whole thing is about this expression, okay? And we learned that we know that the denominator cannot equal to 0, okay? That also means that x is cannot be equal to 1. Oh, sorry, -1. I'm sorry, -1. Okay, but what if I ask you to integrate x to the power of -1 dx? Well, it doesn't work quite well with this formula. Well, that is the reason why when you use calculator or when you use the integral table, stuff like that, they will introduce this one differently. So it's equal to, if I rewrite it in a way where we can see it clearly, it's 1 over x, and that'll be 1 over, sorry, logarithm of, again, absolute value of x plus c. Okay. Now, here's the point. Here's the thing. When we talk about logarithm, natural log of x, okay, we know for sure, the reason why I put in absolute value, because we know for sure x cannot be less than 0. Okay, so it cannot be less than 0, it has to be greater than 0 for sure. It has to be greater or equal to 0, that's for sure. So what happened is, the only problem right now is 1 over x. The 1 over x1, well, x can be any number. But if I ask you to evaluate, now let's bring it to the next page, shall we? So if I ask you to evaluate 1 over x when x is less than 0, okay? Oh, sorry, integrating, sorry. I cannot ask you doing this. This is too ridiculous, right? But if I ask you to integral 1 over x dx when x, it should not be when, but where x less than 0, that for sure what happened is some of you guys were saying, we cannot do this. The reason is all because, again, because of natural log of x cannot be less than 0. But the other way of answering this is, now let's just say, let's just put this one in here, shall we? And we want to integrating this one. Now what okay, sorry, let's forget about it. Okay, let's forget about it. Let's imagine we're differentiating this one. Okay, we're differentiating this one. All right. Now, if I'm differentiating this one, what I get? So there's two scenarios. What happen? Either I'm differentiating as x is positive, or I'm differentiating as x is negative, so it should be negative x. Okay, so now if I'm differentiating this, what do I get? So I get 1 over x plus, because of the chain rule, so I got, this one, right? So it'll be 1 over x, sorry, not plus. Again, I make a mistake of the chain rule. But again, so this one is 1 over x is times, so 1 over x times x, differentiate of x. That's not this side is a differentiate, my notation of differentiation. Again, so this one, the same thing. So I got like 1 over negative x time a chain rule. And now I get like, well, 1 over negative x times negative 1, again, is equal to 1 of x. Okay, so if I ask you to, integrate this, well, for sure, if I ask you to integrating 1 over x dx when where x less than 0, that's also for sure the natural log of absolute value of x plus c. It won't be like no answer at all. Okay, and the second one, about before I closing this topic of indefinite integral, there's one technique I want to introduce to us. Is kind of a little bit complicated to do this, but again, if we have a strong knowledge of integral differential equation, differential calculus, for sure this will be like a simple game. So if you don't know, like if you don't see the solution, I I probably would recommend you to go back and review differentiation again. So if I ask you to integrate this one, okay, what can we do? Like how can I integrate? How can I integrate this? You feel free to pause the video and try to solve it. But like give you a hint is that it doesn't base on any of the properties I listed out there. So you feel free to pause the video and try to solve this one. Okay. And if anyone here already solved it and see the technique, like give yourself a clap. Like clap yourself really hard. Okay. So for this one, for sure, all the properties and everything, all the formula I introduced, they don't work in here. I think they do, but only if we kind of have a strong idea of what is going on. Okay. Now, again, so first, when we started integrating thing, we kind of wanting to bring it to a one, like for we want to ask you to integrate x power n. Let's rewriting this. All right, we want to bring the x, again, we want to bring this power up by 1. Okay, right? So for this is the same thing. Okay, so for this, we generally we don't have a overall formula for this at all. That's why the technique for doing this kind of thing is called guessing. Okay, because I don't even know, like I don't even know whether it's right answer or not, so I'm just guess it. Okay, because we don't have a formula to apply. So the way we do guessing is that generally for me is that I'm started to think what equation, if I differentiating it, can get me to this one. Okay, so for me, I'm trying my best to think of, right, so I know x to the power 1. Okay, so 1 over 2, right? I try to make this one plus 1. Okay, the same thing is 1 over 2 plus 1. Okay, why I think in that way? Why am I not thinking about x about thing? All right, when I start to differentiating it, you get the idea of why. Okay, so again, so let's solve this one, shall we? So it will be 1 over 1 over 2 plus 2 over 2, right? So I just rewrite and do it slowly, and hopefully everyone get my techniques. So 1 over 2 plus 2 over 2, then that'll be 2 over 3 times x plus 1 sorry, 3 over 2. All right, feel free to pause the video and check my math and see how I can get, how I can guess from here to here. So I hope it's a simple math for you. But anyway, okay, so this is my guess. Okay, now I have to prove it. Okay, now I have to prove it. So what I would do is I will try to differentiate this because I want to show that if I differentiate this one, okay, so x plus 1, I eventually will ending up to this one. Okay, that's what I was hoping to show. Okay, so let's just see whether I'm correct or not. Okay, so differentiating this, I will get, so this one times 3 power 2, oh sorry, there's no more space for me to write here. So this one times 3 to the power 2, x plus 1, right? Minus 1, 3 to the power 2 minus 1. So again, this thing canceled out. That leaves me of x to the power 1. All right, so we'll know 1 over 2, and that's exactly equal to this one. Okay, so in the end, I'm just saying, therefore, integrating of this one is right equal to 2 to the power of x. Sorry, 2 over 3 times 1 plus x plus 1, power 3 over 2 plus c. Okay, so this is a technical guessing. Okay, so again, so basically, I'm trying to guess an equation, and I will prove it that it works. If it's off, I cannot find anything. Well, let's just do this one again. Okay, let's just do this one again. And I plus a 2 outside here. Okay, so first I'm gonna guess the same thing. So again, so I'm gonna guess the same thing. Sorry, there's something up here. I randomly click on the wrong one, but let's let's do this one again, shall we? So sorry, suddenly my mind's not working and oh yeah, there's 1 over 2 plus 1, right? And x plus 1, so 1 over 2 plus 1, so that'd be 2 to the 2 power 3 times x plus 1 power 3 over 2. All right. Sorry, this is my equal sign. Okay. So now the problem is I have a 2 out there. Okay, I have a 2 out there. So what I would do is I times this bracket here. So that'll be 4 over 3, So basically is I'm trying to do is that I'm trying to find a way to think of equation. I don't think this one is a good example at all, but I hope I will find a better one in the problem. I will post it in the description. But again, what I'm trying to do is I'm trying to guess an equation so that when it differentiates, it gets the equation as the integrand. So the only because we haven't introduced all the techniques of integration yet. That is the reason why guessing is the only technique we can use, because we can see immediately the solution is, and we just sit down here and prove it. If you don't see it, I would recommend you to try really hard again to review the differential calculus, because that part I believe will help you a lot. Yeah, and that's all for my indefinite integral video. I do have some problems in the description. Feel free to download it and solve it on yourself. If any have any question on the problem, just, leave in a comment. Let me know. Yeah, if you have any comments, suggestion that I need to take, that I need to improve, feel free to leave in the comment as well. But for now, hope to see you in the next video.